All right, welcome back to your stats notes. So what we have here is the final note packet for this unit. So the last thing that we're going to take a look at is just some experimental design approaches, specifically blocking and matched paired, and then how we can write those up and the descriptions that would go along with those. All right. So in an attempt to compare the amount of salmon, the amount of weight salmon gain when raised on an old food versus a new food, salmon have been randomly assigned to the different tanks in the room. All right, so we've got tanks. Here's our room. Here's the layout of the room. One lurking variable that we identify is that the temperature of the room is drastically higher on the side of the room with the heater than on the side of the room with the windows and door. How can we design an experiment to help control for this variable? Draw a diagram and explain your plan in words. All right, so we know there's a difference between this side of the room and this side of the room. So because we know that, we want to try to control it. All right, we don't want temperature to be a deciding factor in our results, because what if when we randomly select, all the new food ends up on the cold side and all the new food, sorry, I don't remember what I said. What if all the new food ends up on the cold side and what if all the old food ends up on the hot side? We wouldn't know whether differences have more to do with food or more to do with temperature. And you might say, well, what are the odds all four are going to end up on one or the other? Well, fine. What if we just end up with 3 new foods on this side and 1 old food, and 3 old foods and 1 new food? All right. Still, heat is sort of a lurking variable that might be affecting our results and muddying the water of whether or not this new food happens. Ideally, we'd have it a little more balanced. All right. We'd make sure that new food and old food were like evenly split between the hot and the cold rooms. All right. And that's exactly what we're going to do. All right. This is something called blocking. All right. We're going to sort of divide the room into a cold side and a warm side. All right. You can kind of think of this as the equivalent of stratified sampling. All right. We saw that a few classes ago where you would break your sample into different groups and then sample separately from each of those groups to make sure that you got sort of a balanced representation. Same idea here. Blocking, which is what we're about to do, is the experiment equivalent to stratified. All right, so we've divided our room into 2 halves, and then what we can do is start generating random numbers. So I could generate, I could say that I'm going to generate, 2 unique numbers between 1 and 4 and give them new food. And then I could go down here and I could say I'm going to generate 2 unique numbers between 5 and 8 and give them new food, or the new food. We'll say the new food. All right. And in this way, I'm guaranteeing that there's going to be 2 new foods on this side, 2 new foods on this side, 2 old food on this side, 2 old food on this side. And I'm balancing it so that I'm controlling for the temperature variations. All right. If the warm and cold are balanced between the 2 groups, I can have more confidence analyzing my results that any differences I'm observing are not from the temperature, but from the actual quality of the food. All right. So in both cases, remaining tanks get the old food. All right, so there's kind of our plan. We've got the cold side, a warm side. We're going to generate random numbers. So kind of a description here that I'm going to write down below is divide the room into a warm block and a cold block, and then randomly assign the foods to the tanks in each block. So effectively, it's almost like you're just doing the experiment twice. It's like you're doing the experiment with the cold tanks and saying, all right, 2 of these are going to get new food, 2 of these are going to get old food. Then you're repeating the experiment down here on the warm side. 2 of these are going to get old food, 2 of those are going to get new food. And then once you've done that, you can kind of combine the results and say, all right, what's the total impact of the new food across warm and cold tanks? What's the total impact of the old food across warm and cold tanks? But this ensures that we're getting a balanced representation and we're not letting temperature be the overwhelming factor in whether we do a good job, whether the salmon growth is high or low. So again, blocking the equivalent of sort of stratified sampling. All right, so with that example in the books, let's actually write down our exact definition. So block is a group of experimental units that are known before the experiment to be similar in some way that is expected to affect the response to the treatment. All right, so each block has some characteristic in common, and that characteristic is assumed to have some impact on response to treatment. All right, if we don't think it has any impact on a response to the treatment, there's no point in making the block. All right, if warm and cold water doesn't matter, there's no point in creating the blocks. You create the blocks when there's a reasonable expectation that that quality could have an impact on your results. So again, I'm going to put the same note here that we put next to strata when we did stratifying sampling, is they are the same within and different between. So within a block, they all share the same quality, and then different blocks are different qualities. So again, like if you were to block by gender, you might have a male block and a female block, and things like that. Randomized block design is kind of the extension. Once you create your block, you still want to use random assignment for all the reasons we previously talked about. All right, you want to try to balance all those other things that we're not considering. You're trying to create 2 groups as similar as possible. So we control the things that we're aware of, and then we use random assignment to try to balance out some of the things that we might not be aware of, so that they're at least as balanced as best as we can between the 2 different groups. So this is the random assignment of experimental the random assignment of experimental units to treatment groups is carried out separately in each block. All right, so blocks are just another form of control to try to make sure that you're getting the best comparisons possible. And basically the same data, the same experiment is done for each block, and the data is combined at the end. All right. So dwarf fruit trees. What does that have to do with what we're talking about? Well, let's read and find out. Students are designing an experiment to compare the productivity of two varieties of dwarf fruit trees. The site for the experiment is a field that is bordered densely by forests on the west or the left side. The field has been divided into 8 square plots of approximately the same area. The students have decided that the test plots should be blocked. A tree will be assigned at random to each of the 4 plots within the block. 2 blocking schemes below are under consideration. Which blocking scheme, A or B, is better for the experiment? Explain why. All right, so remember, you're conducting the experiment kind of almost separately for each block. So you'd either be conducting the experiment once here, where you get 2 different types of trees, and then again here with those 2 different types of trees, or you're conducting it here with those 2 different types of trees, and then you're conducting it here for these 2 different types of trees. So I'm just going to pretend that the 2 fruit varieties are A and B. All right. So which blocking scheme would be better? All right. I'm going to kind of skip ahead and just say that it's this one right here. And I think the easiest way to illustrate that is just by kind of putting some labels down here. So let's just pretend my 2 trees are A and B. If I were to use this scheme, all right, I might randomly end up with all my A trees over here and all my B trees really close to the forest and the shade. All right. All right. That could just be the random distribution. If I randomly assign it, it could end up that I ended up with BB, AA. All right. And then I could go down here. And again, I could randomly end up with something like BA, BA. All right. Let's just say this was randomly assigned. Well, all of a sudden now I have 3 B varieties on the shady side, and I have 3 A varieties on the sunny side. So my results might be influenced not by the variety of tree, but by how much sun they got. And I might come to the conclusion that variety A is better, and it might not have anything to do with variety A. It might have to do with that variety A got more sunlight and it performed better. And if we had flipped these, maybe variety B would have done it better. Compare that to this blocking scheme. No matter what I do, all right, if I say, all right, I'm going to put the B one here and the A one here, and then maybe another A one and then a B one, all right, either way, I'm going to end up with 2 B's in the shade, and I'm going to end with 2 A's in the shade. All right, no matter what I do here, no matter how I space these out, or no matter how they randomly get assigned, I'll just do the flip of this here. Again, randomly assigned, I'm guaranteed to have a balance of B's in the shade and B's in the sun, A's in the shade, A in the sun. This one guarantees a balance between trees, we'll say near the forest and away from the forest. All right, so we're ensuring that that factor is balanced across both groups so that if it does have an impact, it should be impacting both groups equally, and then we can do a more honest comparison between variety A and variety B. All right, so it says, even though the students have decided to block, they must randomly assign the varieties of trees to the plots within each block. What is the purpose of this randomization in the context of the experiment? All right, so it eliminates the potential of bias on the part of the researchers so that they can't influence it by saying, oh, that plot looks a little better, let me put A here, and that plot looks a little worse, let me put B there, and so on and so forth. And creates two groups as similar as possible, hopefully balancing any other factors. All right. So when we know there's a factor like shade versus sun or warm versus cold, we don't leave it to chance. All right. We create blocks and guarantee that the treatment and the control are sort of balanced between those two blocks. But there's no way we can ever be 100% sure that we're accounting for every single factor. So once we've created our blocks and tried to balance it on the stuff we're aware of, we rely on randomization to create two groups that are as similar as possible by hopefully balancing any other factors that we didn't consider. All right, and that allows us to make more honest comparisons between the two groups. Okay, so we block the stuff that we're aware of and try to control for it that way. And then we use random assignment to try to balance the other stuff that, we might not be aware of, and to eliminate any like personal bias on the part of the researchers for whatever stake they may have in the results. Okay. So again, that's kind of the idea behind this block design. So what we're going to do now is sort of walk through the different types of experiments and sort of see how you would write up each of those descriptions to kind of express what's going on. All right, so the setting that we're going to use is this, hypothetical experiment where we're trying to figure out, is there a difference in people's pulse rates when they're standing versus when they're sitting? So we're going to do a randomized comparative experiment of this. Is there a difference between pulse rates when people are standing or sitting? So we're going to make a couple of assumptions here and then use that as our basis. All right. And some of these assumptions are just to make the numbers easy for what we're doing, but they don't really change the approach. So we're going to say that there are 20 people in this experiment. And this isn't going to become relevant to later on, but we are going to say that there are 10 female and 10 males. Okay. So if we were going to do a randomized comparative experiment, all right, what we could do is we could say, all right, there's 20 people in total. So to set up this experiment, we could generate 10 unique random numbers between 1 and 20. All right. Those people would stand. Everyone else would sit. And then we could calculate the average for both groups. All right, and then we'd have the mean standing and the mean sitting. All right, and if this wasn't a video and we were live, we'd probably actually do this and kind of gather the data, but you get the idea. We've got 20 people in total. We want to make sure that they're randomly assigned, so we generate 10 unique. That word unique is important there. Random numbers between 1 and 20. Those people would stand, everyone else would sit, and you could have reversed that and said those people would sit and everyone else would stand. And then we would calculate an average for each group. So that's kind of basic randomized comparative experiment. Completely randomized comparative experiment. All right, so this is a little different. So we still have our 20 people in the room. 20 people, I don't know, I was going to write there. 20 people in total. We would generate a random number one or two for each individual. Okay, and then anyone with a 1 would stand. Anyone with a 2 would sit. And then again, we would just calculate the average for each group. All right, so what makes these two different is this one I guaranteed that the two groups were going to be balanced because I said I'm generating 10 unique numbers, and then whatever 10 are left over automatically get the other treatment. Whereas this one, I totally left everything up to random assignment. So every person received a random number, and based on their number, they were either standing or sitting. I mean, ultimately, it's probably going to be pretty similar to this. And as the samples get larger, I mean, these two are going to just become closer and closer. But this, again, is called completely randomized, where we don't force the groups to be equal. And this would just be randomized, where we sort of ensure that it's going to be balanced out. All right, so third one here, blocking by gender. So that's what we kind of just talked about today. So this was from sort of the previous class. This is today's. How does this differ? All right, so we still have 20 people in total. So we can create a block of 10 females. That's step 1. All right. And then for those 10 females, we could generate 5 unique random numbers between 1 and 10. Those people would stand. All right. Everyone else would sit. All right, then we're basically repeating the process with the male block. All right, so we're repeating the process with the male block. Then again, you know, at the end, we're combining the male and female standers and the male female sitters to calculate the averages. All right, so in this case, we do it separately. We say, all right, here's our group of females, here's our group of males. Let's ensure that 5 females are standing and 5 females are sitting. Let's ensure that 5 males are standing and 5 males are sitting. We conduct the experiment, but then we can combine the standings and the sittings together. All right, so we know that our final average for the standards is going to have 5 males and 5 females be a part of it. Our final average for the sitters are, again, going to have 5 males and 5 females. We're balancing the gender across both things to make sure that that effect is controlled for, so that we don't randomly end up with more females in one group or randomly end up with more males in another group, since we're aware that that might have some sort of impact. Okay, so again, just different ways of writing up the same. So it's the same experiment, you know, standing versus sitting. And this is 3 different ways to sort of design the experiment and conduct your research. All right. Generally, if you know that this characteristic is important, like if you know that gender makes a difference, then blocking is going to give you the best results. If it turns out that, you know, gender doesn't have any role in what to play in this whatsoever, then blocking may actually be counterproductive, because it might end up sort of creating one group that's very different than another group, and you might not get the same balance that you want if other things are like correlated or it's messing things up. So again, if you know that this characteristic male female has an influence on your results, then yeah, you should block. If there's no reason to think that it does, then you should go with, you know, one of these 2 approaches. All right. One last type of experiment to talk about, and then we'll wrap it up for the day. So this is the matched pairs experiment. And this is a common form of blocking for comparing just 2 treatments. All right, and then there's 2 general ways that it's done. All right, so way 1 is that each subject receives both treatments, but in a random order. And then way 2 is subjects are matched in pairs as closely as possible. So subjects are matched in pairs as closely as possible. And then each subject in the pair receives one of the two treatments. Okay, so you either have the same person get both treatments, but you randomize the order, or you try to find people as similar as possible. So it might be that they are the same gender, it might be that they're the same age, it might be that they're the same weight, it might be that they have the same physical activity level. You're trying to create two people that are or you're trying to find two people that are as similar as possible, so that the only thing that's different between these two people is whether or not they receive the treatment. This is one of the reasons that researchers love identical twins, because presumably they're about as similar as you can get. And then you know that the only difference in your experiment between these two people is whether or not they're receiving the treatment. So again, if you happen to be an identical twin, you probably could have a long, maybe not long, but fruitful career as like a lab rat, a human lab rat, where people just test all sorts of things on you. Depending on how much gets tested, that's why the career might not be very long. But you get the point, is they're trying to match people up as closely as possible, and then one of them gets one treatment and one of them gets another treatment. It's basically just taking blocking to its absolute conclusion. It's saying like, okay, not only are we worried about warm and cold or shade and sun, but we're going to worry about everything as possible, as many things as possible. We're going to create a whole bunch of pairs, or like just really tiny blocks, and then make sure that in each of those pairs or really tiny blocks, one person gets one treatment, one person gets the other, so that you're balancing all those factors as much as possible. All right, so we're going to look at the before and after scenario. So again, we'll stick with the 20 people in the study, the same as all the other ones, so we'll be consistent. And what we could do is we could say, all right, we're going to generate 10 unique random numbers between 1 and 20. Those people start by standing and then sit. Everyone else starts by sitting and then stands. Now, the major difference when we do this type of study is, instead of calculating a standing average and a sitting average, we instead examine the average difference between the before and after. All right, so if when you were sitting, your pulse rate was 70, and when you were standing, your pulse rate was 80, we might say that the average difference was, 10 there. And then instead of looking at the 70 and the 80, we'd be focused on that 10, the difference between those two values. All right, so we look at the mean difference when we're doing a matched pairs experiment versus looking at the individual groups like we did for these three right here. All right, so these three we're all looking at mean standing, mean sitting, mean standing, mean sitting. This one, you know, we did block by male and female, but at the end, we did reduce it back down to mean standing, mean sitting. Whereas this last one here, when you're doing the before and after kind of matched pairs type setup, instead you're going to look at the mean difference between the before and the after, right? And kind of see what that change is. Because again, it might be that like standing first versus sitting first impacts like just your overall average. So instead of looking at the raw numbers, we look at the differences between those two. All right. So I hope that was pretty clear as far as kind of, you know, the different types and sort of how you write up these descriptions. If you had any questions about anything or you need some clarification on something, obviously just reach out and we can go from there. All right. Have a great day.